Welcome to the AI and GIS Frontier podcast. Let's get into today's topic.
Today we are talking about AI for climate and environmental monitoring. This is where geospatial AI has some of its highest stakes applications, and the progress in the last year has been remarkable.
What are the headline developments?
The biggest is NASA and IBM releasing Prithvi Weather Climate, a foundation model pre-trained on 40 years of atmospheric data from NASA's MERA-2 reanalysis dataset. This model can do weather forecasting, climate projections, and air quality prediction. But what makes it transformative for GIS professionals is that it connects atmospheric data with surface observations. A forest fire risk analyst can now integrate weather predictions with vegetation dryness indices from satellite data in a single framework rather than cobbling together separate models.
How accurate are AI-based environmental predictions compared to traditional methods?
The numbers are impressive. AI-driven flood detection is hitting 92% accuracy, wildfire modeling is at 89%, and tropical cyclone tracking errors have been significantly reduced. Machine learning downscaling captures local precipitation extremes better than traditional statistical methods. For a forester, the flood and fire numbers matter most. If you are planning harvest operations in a watershed, knowing flood risk with 92% accuracy affects road building decisions, stream crossing designs, and timing of operations. That level of reliability is approaching what you need for operational decision-making.
Tell us about the ESA CO2M mission.
The Copernicus CO2 monitoring mission, launching in 2025 and 2026, will quantify greenhouse gas concentrations from space. This provides an independent, transparent basis for emissions tracking. For environmental consultants working on carbon offset projects, this is huge. You will be able to verify carbon sequestration claims in forestry projects against satellite measurements. A timber company claiming their reforestation project sequestered a certain amount of carbon will have their claims independently verifiable from orbit. It changes the entire accountability framework for forest carbon markets.
How are forestry organizations using climate AI right now?
The most immediate application is fire risk modeling. Provincial and state forestry agencies are integrating AI weather predictions with fuel type mapping and terrain data to produce daily fire risk assessments at landscape scale. In British Columbia, the fire management branch uses machine learning models that combine satellite-derived vegetation moisture indices with weather forecasts to identify areas of emerging fire risk days before traditional methods would flag them. That early warning window can mean the difference between a controlled, prescribed burn and a catastrophic wildfire.
What about broader environmental monitoring?
Climate AI is revolutionizing how we track environmental change. In the boreal forest, AI models are detecting permafrost thaw patterns from satellite time series, identifying areas where melting is accelerating, and infrastructure like logging roads and pipeline corridors may be at risk. For watershed management, machine learning is being used to predict stream flow changes under different climate scenarios, which directly affects water licensing for forestry operations and environmental flow requirements. Coastal environmental managers are using AI to model sea level rise impacts on wetland habitats with much finer spatial resolution than was previously possible.
NVIDIA showed some interesting work at GTC 2025.
NVIDIA is investing heavily in climate AI infrastructure. At GTC 2025, they showcased GPU-accelerated climate models that run orders of magnitude faster than traditional approaches. For GIS professionals, this means climate projection data at much higher spatial resolution becomes available. Instead of climate projections at 50-kilometer grid cells, you get 1 kilometer or finer. That resolution matters when you are trying to model how climate change will affect a specific forest management unit or watershed. A forestry company planning which species to plant on a reforestation site needs local climate projections, not regional averages.
What should environmental GIS professionals be doing to prepare?
3 things. First, get comfortable working with climate data in your GIS workflows. Learn to pull data from NASA Earth data and the Copernicus Climate Data Store and integrate it with your spatial analyses. Second, start incorporating climate projections into long-term planning. If you are doing a forest management plan with a 20-year horizon, the climate in year 20 will be meaningfully different from today. The AI-powered downscaled projections make it feasible to account for this. Third, watch the carbon monitoring space closely. As satellite-based emissions verification becomes operational, it will create new requirements and opportunities for environmental GIS work around carbon accounting and offset verification.
The intersection of climate science and GIS is clearly going to be one of the most important application areas going forward. Thanks for the overview.
Thanks. The tools are getting better, and the data is getting richer. GIS professionals who can bridge climate science and spatial analysis are going to be in very high demand.